Precision versus accuracy. Accuracy is defined as the closeness of a measurement to the true or accepted value. True or accepted values are standard values based on substantial experimentation. Precision is the closeness of agreement of two or more measurements of the same quantity. It can be quantified using standard deviation of the mean. A smaller standard deviation compared to the average is more precise than a larger standard deviation. Are the arrows precise or accurate? Because the arrows are close together in the first target, they are precise, but they are not accurate because they're not close to the middle. In the second target, the arrows are neither precise or accurate because they're scattered throughout the target. The accepted value for the density of iron is 7.87 grams per cubic centimeter. Using the average values of the three measurements from both groups below, which is more accurate? To find which is more accurate, we first have to find the average of each dataset. To find the average, we have to add all the numbers in the set. Then we divide by how many numbers there are. When we add 9.67, 6.56, and 7.23 for group A, we get 23.46, which we then divide by 3, giving us an average of 7.82 for group A. For group B, we add 9.02, 8.90, and 9.50, giving us 27.42. When we divide by 3, we get 9.14 as the average. When we look at both averages, we can see that Group A's average was closer to the accepted value for the density of iron. Because of this, it is accurate. Although Group B was not accurate, their values were precise as they were all close together. A teacher tells her class to measure the distance between her classroom and the cafeteria. However, no measuring tools could be used. Each group of students conduct 3 trials using different measuring methods, such as the length of their arms or their feet to find the distance. If the true measurement between the classroom and the cafeteria is 237.0 feet, list whether each group of data is precise or accurate. We're going to start off again by finding the average for each group. When we add all the numbers in group 1, we get 633.98. Divide by 3 and we get an average of 211.33 feet. Because the average is far off from the true measurement, it is not accurate. However, since the numbers are all close together, the data is precise. When we add the numbers in group 2, we get a value of 710.24. Divide that by 3 and we get an average of 236.75 feet. Since this value is close to the true measurement, it is accurate. And since the numbers in the dataset are all close together, it is precise as well. When we add the numbers in group 3, we get 758.5. When we divide this number by 3, we get 252.83 feet as the average. Since this value is far off from the true measurement, it is not accurate. It is also not precise because the numbers in the dataset are not close together. Lastly, for group 4, when we add 397.60, 70.40, and 243.00 feet, we get 711. When divided by 3, we get 237. which is the true value. However, since the numbers in the dataset differ greatly, we cannot consider this data accurate just because the average equals the true measurement.